I want to go through a type of tricky question examiners like to give students. You'll often see questions where you have two people or machines that perform the same task at different rates. So here we've got Ross and George, who are book editors, and they edit novels at different rates. George takes 8 hours longer than Ross. So these types of questions typically tell you something about their performance when working together. So here, we're told that Ross and George can edit a novel in 7.5 hours if they work together. And then typically the question will ask you what would happen if one of the two worked individually. So here we want to know how long would it take Ross to edit a novel if he was working alone. So I've gone ahead and defined T as the time it would take Ross to edit one novel by himself in hours. Since this is what we're trying to find, it makes sense to define it as a variable. And if Ross takes T hours to edit one novel, then George, since he takes 8 hours longer, is going to take T plus 8 hours, right? Okay. So when Ross and George are working together, they're completing different portions of the novel, right? So Ross might be editing, I'll just move this down slightly. So for example, Ross might be editing, let's say, he could be editing 2/3 of a novel, right? And George might be editing 1/3 of the novel, just as an example. But it adds up to 1, okay? So the fraction that Ross edits and the fraction that George edits is going to add up to 1. We can expand this a little bit further as follows. So the portion of the novel edited by Ross is the time that Ross spends working multiplied by Ross's work rate. Okay, the work rate, the units for work rate are, in this case, novels per hour. So his work rate is how many novels he can edit in an hour, right? And the time, the unit for time is obviously hours, right? So, hours can be written as hours over 1. You can see when you multiply these together, these will cancel and you'll just get novels. So for example, you might get 2/3 of a novel. That just sort of confirms that we're on the right track because the units all look fine. So I'll leave that there. The work rate is, actually, I might be short on space, so I'll write that here. Novels per hour is the work rate, okay? And do we know any of the things in this equation? Well, yes, we do. We know what the time spent working is because we're told that if they're working together, which is what's happening in this equation, then they can edit a novel in 7.5 hours, right? So the time spent working together is 7.5 hours, right? So 7.5 times Ross's work rate. So if you take that and then if you add, again, 7.5 hours because George is also working for 7.5 hours in this case, and you multiply that by George's work rate, you're going to get 1, right? I've just put this asterisk, this red asterisk here, to emphasize that this is George's individual work rate and this is Ross's individual work rate. Okay, so they're going to be different numbers because they both work at different rates. Okay, well, to solve this equation, we need to find what their work rates are. How can we do that? Well, let's look at what happens when Ross is working individually. If Ross is working individually, we know that the work rate is in novels per hour, right? That's what we explained here. And based on our definition of T, he completes one novel in T hours, right? That's what we define T to be. We define T to be the time it would take Ross to edit one novel. So if we divide both sides by T, we can get I'll do that in blue. We get 1 hour corresponds to 1 over T novels, right? And that's just his work rate because his work rate was in novels per hour, which is what we'll get if we divide this by 1. So this means that the work rate is 1 over T novels per hour, right? Because in 1 hour, Ross can complete 1 over t novels. Okay, we do the same thing for George. So George takes t plus 8 hours to complete 1 novel. That means that in 1 hour, he would complete 1 over t plus 8 novels. Therefore, his work rate is 1 over t plus 8. Okay, so again, t plus 8, just to remind you, because we figured out over here that if Ross takes t hours to edit a novel, George is going to take t plus 8. Now all we have to do is substitute those work rates into this equation that we have here. Okay, we can call this equation A, and we just need to sub what we got into equation A, and then we should be able to solve for t. So sub into A. Okay. So what happens when we sub it into A? This is what we get. So we get 7.5 times the work rate. So 7.5 times Ross's work rate, which was 1 over t, plus 7.5 times George's work rate, which is 1 over t plus 8, which is equal to 1, right? And then I'm just going to go ahead and solve this. So what I'll do is I'll break this up into fraction form just to make things a little bit easier. So what does that become? That becomes, so 7, that's the same thing as 15 divided by 2, right? So 15 over 2t plus 15 over 2t plus 8 is equal to 1. I'm going to multiply both sides by 2 to get rid of these 2's. So that's going to give me 15 over t plus 15 over t plus 8 is equal to 2. Okay, I'll keep going. So I need a common denominator. So 15 times t plus 8 plus 15t over t plus 8 is equal to 2. Yeah, I hope that makes sense. What I've done there is, to get a common denominator of t times t plus 8, I've multiplied this by t plus 8 on the top and bottom, and then multiplied this by t on the top and bottom. Okay, so that's, we end up getting this. Okay, just gonna bring everything to this side. Whoops. Okay, so I'm gonna bring this denominator over to the other side. So this becomes 15t plus 8 plus 15t is equal to 2t t plus 8. Now we're just going to expand. We get 15t. What's 8 times 15? Well, it is going to be 120, I believe. Yep. Plus 15t gives us 2t squared plus 16t. So you can see we've ended up with a quadratic. That's why this is related to the topic of quadratics. I'm just going to bring all these terms to the other side. So what's that going to give us? We'll have a 0 here. We'll have a 2t squared. Okay, we've got, I think it's going to be a minus. So we've got 16 minus 30, because we're bringing both of these. So that'll give us negative 14 minus 120. Okay. We can divide both sides by 2. So I'm just going to sort of swap the sides around. That's 2t squared minus 7t minus 60 is equal to 0. Okay, can we think of two numbers that multiply to give negative 60 and add to give negative 7? So 12 and 5 are both factors of 60. So what if we broke it up like this? So negative 12t plus 5t. That, when you add them together, that gives negative 7, right? And when you multiply negative 12 and 5, that gives you negative 60. So that works. So then this is going to factorize to t minus 12, and t plus 5 is equal to 0. And using the null factor law, you get t is equal to negative 5 comma 12. Now, it doesn't make sense to get a negative answer, right? So we reject t is equal to -5 because t has to be greater than 0. Because you can't complete, because t is talking about how fast Ross can edit a novel, and it doesn't make sense to say he can edit a novel in -5 hours. And therefore our answer is 12. So we know, therefore, Ross can edit a novel alone in 12 hours. Okay, so it's important to understand these types of questions, so feel free to go through that again. I also have this website. So this website lays it out in a similar way that I've done. They use a slightly different example on this page. Their example is to do with envelopes, I believe, and machines that seal envelopes, or something along those lines. So check out this page for if you want more information about this.